In this tutoring video, I'm going to go over problems similar to what you saw in the Factoring Expressions 1. So we're going to look at problems that have difference of squares. So the very first thing I'm going to do is I'm going to locate 9 and 16. We can see 9 and 16 are in fact perfect squares. This breaks into 3 and 4. I'm going to divide 2 by 1. Now the next thing I'm going to do is I'm going to fill in the spaces. The 3's and A's come from the front. The 4 comes from the back. 1 is positive and 1 is negative. How can you tell if you did it right? Well, if you FOIL this, you should come back with the original expression because this expression and the secondary expression are equivalent. This is an expanded form and this is contracted or factored form. So FOILing front, outside, inside, last. If you chose to see if you did it right, you can multiply the fronts 3 times 3 and there's 2 A's. Multiply the outsides, negative 12A, multiply the insides, positive 12A, and multiply the last, 4 times negative 4. We can see the 2 middles cancel, and I'm left with 9A squared subtract 16. I just proved to myself that I correctly factored this original expression. Okay, let's look for 25 and 9. 25 is 5 times 5, 9 is 3 times 3. And now I'm going to divide this by 2 to get c to the first and c to the first. So the 5's and the c's come from the front. In the front place of both parentheses, I'll put a 5c. The 3's come from the back. One's going to be positive and one's going to be negative. It doesn't matter which one is positive in between and which one is negative. And again, if you went through and you FOILed this, we'd come up with the original expression. 36 and 1, 36 and 1. 36 is 6 times 6. 1 is 1 times 1. Dividing this by 2, 2 divided by 2 is 1. So the 6 F's come from the front. The 1's come from the back. 1 is positive and 1 is negative. 121 and 64. 121 is 11 times 11. 64 is 8 times 8. Splitting 2 in half is basically what we do when we divide it by 2. 11's and G's come from the front of this original expression, so it remains in front. 8 comes from the back, it will remain in back. 1 will be addition, 1 will be subtraction. Let's find 449. 400 is 20 times 20. 49 is 7 times 7. Splitting G squared in half, so 2 divided by 2 is 1. 20, H comes from the front. 7 comes from the back. 1 is adding, the other is subtracting. Okay, 169 and 225. 169 is, let's see, do we see it here? Here it is. 13 times 13. 225 is 15 times 15. So 13's, and again, when we divide this 2, we get 1, so 13K and 13K, and in back we have 15 and 15. In between, 1 is addition and 1 is subtraction. Let's look at these 3 problems. So 50 and 8, we can see 50 is not a perfect square. Let me move this down to the bottom so everybody can see. 50 is not a perfect square. 8 is not a perfect square. It's not on the list to the right of the equal signs. What do? We're going to go to the smaller of the 2 numbers, and I'm going to write down all the numbers that nicely divide into 8. Now, if you're struggling with that, take 8, divide it by itself. We're going to work all the way down. So we know 1 and 8 go into 8. Let's try 8 divided by 2. 8 divided by 2 is 4. So here are the 4 numbers that nicely divide into 8. Now I'm going to go to the larger of the 2 numbers. I'm going to divide it by 50, divided by 4, divided by 2, until I find one that divides and provides me a whole number. Nope, doesn't work. Nope, doesn't work. Okay, 2 is the first number to work, so I was able to factor out a 2 and I ended up with 25. So I can factor out a 2, and I end up with 25j squared, bring down the subtraction sign. And now 2 times what is 8? And if you're not great with those number sense, take 8 divided by 2 to get 4. Let's look for 25 and 4. Okay, 25 is 5 times 5. 4 is 2 times 2. Don't forget about that 2 that we factored out. Okay, so the 5's come from the front. They're going to remain in front. If I divide this by 2, 2 divided by 2, if we're split it in half, it's just j to the first. And we have 2's in back. 1 is addition and 1 is subtraction. Let's go on to the next one. Okay, 192 and 75. 192, no, and 75, no. Okay, they do not work. Okay, so 192. Well, what can I do here? Well, let's go with the smaller of the two numbers, and I know 175, and let's see, what else do I have? So let's divide 75. I know 2 doesn't divide, I know 3 doesn't divide, I know 5 will work. So you can see when I divide here, I'm getting, 3 works. Can't forget about 3. I know 5 would work as well. Whoa. Okay, so I'm going to try these numbers. I always start with the largest. So 192 divided by 75 does not work. 192 divided by 25, nope. 192 divided by 15 does not work. But when we divide it by 3, eventually we're going to see it does work. I can factor out a 3. So I'm going to factor out a 3. We can see 192 divided by 3 is 64. Now 75 divided by 3 is 25. Let's look for 64 and 25. 64 is 8 times 8. 25 is 5 times 5. Okay, 8 times 8. Oops. So splitting this in half is 1 and 1. And this is 5 times 5. 1 adding, 1 subtracting. Don't forget about the 3 that we factored out. Now, we could leave it in this form, we'll see later on, but think of this as cutting out this tile and cutting out this tile and then rewriting it. Okay, so 162. 162. I don't see it on this list. It's not there. 18. It's not there either. So I choose the smaller of the two numbers. 1 and 18, 2 and 9, 3 and 6. And I'm just going to go 162 divided by 18, divided by 9, 6, until I find one that works. No? Oh, hey, I can divide out an 18. Great, so let's divide out an 18. Now, when I divide it by 18, I get an answer of 9. 18 times 9 is 162. 18 times 1, 18 times negative 1 is negative 18. And so I'm looking for the inside, 9 and 1. 9 is a perfect square, 1 is a perfect square. One's addition and one's subtraction. Let's look at another set. Okay, let's look at 3 more problems. Moving this down so you're able to see the entire. Okay, so I'm looking for 25 and 144. Okay, here's 25, 5 times 5, and 144, okay, 12 times 12. Great. 5 times 5, 12 times 12. So the 5s will go in front because they come from the front. The 12s will go in back. And now let's look at, can I continue to do this? Well, I have subtraction, that's a must. And also, the exponents on the variable must be divisible by 2. That means that you must be able to split this in half. So if you split 8 in half, which means you divide it by 2, you're left with 4. So A4 and A4. Why did I put it with A? Because it comes from the front, in front of the subtraction. The C comes from back, so it's going to be with the 12s. Now if I cut 10 in half, I'm left with 5 and 5. 529 and 49. 529 and 49. Okay, 529 is 23 and 23. 49 is 7 and 7. Okay, so I have subtraction, and I can divide each of these by 2. They're even. All even numbers are divisible by 2. Okay, so 23 is going front. And when I divide 4 by 2, I split it in half, I get 2 and 2. All of this comes from the front. In back, 49 is 7 times 7. And I split this in half to get 3 and 3. One's addition, one's subtraction. 98 and 128. Okay, 98 is not here. And 128 is not here either. They're not perfect squares. So take the smallest one, 98, and let's break it down here. So I'm going to grab the calculator and take 98. I know I can divide it by 1. Let's divide it by 2. So 1 and 98, 2 and 49. 98 divided by 3, no. 98 divided by 4, nope. 5 won't work. 6 doesn't work. Divided by 7, okay, 7, 14. 8, nope. 9 will not. 10 will not. Whoop. I know 10 won't. 11 will not. And as long as we get up to 14 here, we've checked everything. 12 does not. Okay, we've checked everything now. Okay, ready? So now I have all the numbers that divide nicely into 98. Let's check those with 128. 128 divided by 98. Nope. 128 divided by 49. 128 divided by 14. 128 divided by 7. And 2 is the first number that works. Okay, I'm going to rewrite this. It's like I'm going to cut that out and cut that out. And you can flip them. Just like 2 times 3 is the same answer as 3 times 2, we can put this in the other order. 128 is from front. 98 is in back. Positive 128 is in front. Negative 98 is back. Okay, so I'm going to factor out a 2. When I take 128 and divide it by 2, I'm left with 64. When I take 98 and divide it by 2, I'm left with 49. Now I'm going to grab that paper again. 49 and 64 are both perfect squares. I choose by taking 7 times 7 and 8 times 8. Splitting this in half, I get m to the first, m to the first. Splitting this in half, I get h to the 8, h to the 8. So don't forget about the 2 up front that we already factored out. 8m is in front. 7h to the 8 is in back. 1 is addition and 1 is subtraction. Hopefully that helped.